the waiting room is slowing down a little bit, so I think we can get started. If that sounds good, Annie.
Sounds good.
Cool. Yeah, so thanks again for everyone joining. This evening there was a change of programming, so if you missed my email earlier, our talks got moved around. So we have our restoration director, Annie Bauer-Civiello, here to talk about fish and the marine heat wave using the last 20 years of Reef Check data in California. It's really cool stuff. I've heard it. So you're in for a good evening. A little bit about Annie. She is, like I said, our restoration director based in the Central Coast Monterey Bay area, and has also been a part of Reef Check in Australia, and so has a long background in the organization, and I'm excited to have y'all hear her give this talk. So Annie, I'll let you take it from here.
All right. Can you see my screen okay?
Yeah,
Like
it looks good.
okay. I had everything set up and ready to go. And as soon as the meeting was going to start, my computer decided to reboot. So, you know, you always having fun with these things when you're okay. So thank you for joining us this evening. I really appreciate it. I wanted to take a couple minutes just to kind of give you a intro as to what I'm presenting in today. So this talk was originally developed for WSN, which is a Western Society of Naturalists conference that was back in November. It's pretty short. It's about 15-minute presentation, but I thought, or we all thought, that it would be meaningful to share with our volunteers. Um, Historically, much of our data that you've helped collect as a Reef Check volunteer has been primarily used for others, so whether that through science or management, but we're now intentionally or trying to be much more intentional about using our own data to tell our own stories, publishing results, presenting findings, highlighting the impact that Reef Check volunteers or you have been directly contributing to. So, for example, we're really close to publishing a manuscript on the restoration um, data that's project that's heading in Big Sur, and then this is another talk, or that's kind of in that step of the same direction that we're hoping to publish. So with that in mind, I I'll begin. Also, I know some of you already have your screens on, which is, I will also say, is really helpful to me because it's also really still, no matter how long or how many times I've done this, disorienting to talk to a computer screen. So thank you for those of you your camera on. It makes me feel like I'm actually talking to people rather than just to myself. Um, and let's begin. Let's see if I can do this. So today I'm talking to you again, like as Jackie mentioned, the before and after marine heat wave, fish community changes in Northern and Central California. So I don't think I have to really go too much detail in this because most of you or every one of you already know this story, but in 2014 to 2016, many of the kelp forests on the West Coast transformed into barrens. This began in September 2014 as the blob, a marine heat wave that just came rolling through, and then was followed up by an El Nino event that went from 2015 to 2016. And then in California specifically, there was two regions hit the hardest, Northern California, and then also in Central California, particularly in the Monterey Bay Peninsula. A lot of you have seen these types of graphs before, but this is specifically using Reef Check data and looking at our long-term monitoring results over time. This is specifically in Northern California, looking at bull kelp density. And that gray bar indicates that marine heat wave event. And you can see a steep and sharp decline starting in 2014, really, in Northern California. And then that magic number that you hear all the time, that over 90% of the northern kelp forests were lost. Just a quick note, that number above the dot point is the number of sites that we use to take the mean. And you'll see that for the next couple slides in Northern California. In Monterey, we saw a very similar story. So for giant kelp, we saw that more of a steady decline rather than a steep, like hit the ground, and it's been basically zero since. Um, but interestingly, what we don't talk about a lot, we had this weird blip of bull kelp density that increased from about 2019-ish to 2022, and it's then declined more recently back to baseline densities. But there's this weird change that happened specifically in Monterey. And then, of course, we had that rapid increase of urchins. So on the top is the purple graphs are the purple urchins, the red graphs are the red urchins. And in both Northern California and Central California, we saw that rapid increase almost immediately after and during that heat wave event. So what we're specifically interested in is what happened to the fish. So we are used to seeing this beautiful kelp forest ecosystem with lots of different types of fish on our surveys, but once the kelp was lost, what happened? Where did the fish go? How did that impact those communities? And this is important because this is a fish response. The marine heat wave happened 10 years. So this is a 10-year response right now. And obviously they have their own economic importance and ecological importance. Rockfish alone generate millions of dollars in economic input for recreational and commercial fishing alone. And we thought there would be a potential slower response rate to this impact event because fish, for the most part, are longer lived species. And when we were looking at this data early on, we weren't seeing immediate results. But 10 years later, let's see. So our research questions were how does density, species richness, diversity, and evenness change before and after the heat wave, both in Northern California and Monterey? And how did fish community composition change, or did it significantly change before and after the heat wave in Northern and California and Monterey? So just to take a pause, bear with me, but I just want to make sure that everybody understands these different terms, because there's often a lot of confusion even in the scientific community. And I just want to make sure that everybody understands what I'm trying to say before I continue on the talk. And I apologize if the next couple slides breaks it down too much, but just bear with me. So species richness is the measure of how many species that we observe on a survey, for example. So when we are doing fish surveys, we're looking at specific species and we're counting how many fish were in that species. So if we look at this slide and pretend that each color is a different species, we see four different species of fish here, and then a total of 10 altogether. That's the density of fish, but the species richness is 4. Species evenness is how balanced those species are. So, or how evenly spread. So for example, in the same instance where we see 4 different species, some species are more prevalent than others. Like for example, the orange species, a more of a rare species than that black species that has more available. So orange, sorry, I forgot that I circled this, than the black. And then the species diversity is a matrix that combines the two. So how many different kinds of species, as well as how well is the species balanced. So on the left, for example, of that blue line, we see 10 fish. Again, we see 5 different species, and they're evenly distributed. So that is a more diverse ecosystem than on the right side, 10 fish, 5 different species, but we have some rare species in there, so that's a less diverse. So each one of these terms have their own nuances and are equally important um, when you're looking at ecosystem health over time. But oftentimes you'll hear people only use diversity because it combines those two terms basically. So again, low diversity is few species and maybe one species dominates versus high diversity is many species in a balanced community. Okay, so just going back, that just a quick pause and going back to the research question. So again, we're looking at how fish densities changed, species richness, diversity, evenness before and after the heat wave, and then how did community composition, which is basically the same way, but another way to look at it. Same term. Of course, all this data is collected by our lovely, amazing volunteers, which was amazing to showcase at the conference. And I don't have to go through this because you all know what our fish monitoring protocol is, but this was a slide to showcase how we collect that data. So what I did was a bunch of statistics. So for richness, diversity, and evenness, I used our long-term monitoring data and ran some mixed linear models. And then for comparing how fish community changed, I took a snapshot of time immediately before the heat wave, so 2011 to 2013, and then 10 years after the heat wave, 2022 to 2024. And then I ran a Permanova and an NDMS plot for those, which I'll talk a little bit about later too. For these, I selected specific sites that were monitored across all years. So there was like a subset. So if there happened to be a site that we started monitoring, for example, in 2018, like a relatively new site that wasn't included in this analysis. So for the Monterey Peninsula, that included 15 sites. And then in Northern California, which was north of the Golden Gate Bridge, included 9 sites in the analysis. So a brief pause to look at a beautiful kelp forest scene because I'm about to show a bunch of graphs. So it's nice to kind of take a break of all the sciencey stuff and remember why we're doing this in the first place. Okay, so just looking at the diversity changes over time. So this is taking a mean across all of those sites I mentioned before in Northern California and Monterey. So, and again, that gray bar there indicates that marine heat wave event. So we see a significant decline. So those red words on the right are basically the statistics, so showing that they're significant. Looking at species richness, again, we're seeing a significant decline for both regions. And then evenness, the same thing. We're seeing a significant declining trend for both regions as well. And honestly, what's interesting about this is despite the differences in kelp loss over time, so there was a steep and immediate decline almost for Northern California versus that kind of steady changing community composition in kelp forests in Monterey, we're seeing the same order of magnitude difference and decline of all these metrics that we're looking at. So again, what we did for the next part of statistics is that I took that snapshot of time before the heat wave, which is indicated in blue, and again, the 3 years, a 10-year difference after the heat wave in red. So that color pattern will be the same in the next couple slides. So this is an NDMS plot. So an NDMS plot is just a way to show how different or how sites are most similar to each other based off of what the species were found. And so basically, this shows how fish communities were structured, again, before, which was in blue, the blue circles, and after, which is the red triangles. And each point represents one of the 9 sites that we used in Northern California. So all these numbers just suggest that like the stress means that this is a good fit. And then the Permanova explains that there's an 11% of the variation after accounting for site variability and that it was significant. So just to kind of dive in, can you see if I do this, can you see yeah,
Yeah.
cool. So, so just to look at specific sites maybe that you might be familiar with, Portuguese Beach actually here was one of the sites that, okay, let me back up. The further away from each other, the more different these sites are before and after, versus some of these sites that are, this Gersel Cove here, that this one's closer together. That means that these two sites before and after the heat wave are still quite similar to each other. So, for example, Portuguese Beach, which is one of the restoration sites now in Northern California, which was only started because it was one of the last sites that had kelp remaining and that they wanted to protect that particular site, still had quite a huge shift in fish community composition before and after the heat wave. Same thing for like Mendocino Headlands. There's a pretty big shift. But like for Ross and Ocean Cove, they all kind of remained relatively the same within that 10-year period. So the fish that had significant responses and densities was, for Northern California specifically, was the cabezon and the kelp rockfish. But we didn't see any significant responses. I should say this is taking that snapshot in time. We're not looking at the natural variability of the fish, like in the long-term monitoring, but we're just taking a piece of time before and after the heat wave. So like black and yellow rockfish, grass, black, rockfish, China, I mean, all of these did not show a significant response. Same for perch, interestingly. I mean, rubber lip looked like it was a huge decline, but really it was so small. I think like 1 year we saw one rubber lip, and then after that we saw none. So it looks like it's this huge decline, but it's really just looking at 0 to 0. So, and then looking at Monterey, so remember in Northern California, it was 11% of the period. The period explained 11% of the variation versus in Monterey, it's actually higher. And that was 17% of the variation. Again, that blue is the before period and the red is the after. And you're seeing a much bigger shift in community changes before and after the heat wave in Monterey. And again, just to point out some specific sites that you might be familiar. So for example, Lover's Point had a pretty big shift in fish community composition, like Pescadero, North Monastery, Lovers, all right, did I mention Lover's Point? I can't remember. Anyway, Point Joe are all some that kind of that showed this big significant change in fish community composition. And then the fish that we had that showed significant responses in Central California or Monterey was black rockfish, brown kelp greenling, kelp rockfish, lingcod, senoritas, and striped perch. I don't have another slide with the non-significant responses, but I think you get a good understanding of there was more fish. And I think the reason why is that tends to be more of a diversity of fish in Central California than Northern California. Also, there is Northern California fish are really hard. Fish surveys are really hard to do. It's often tough weather. There's low vis. So there's all those kind of variabilities to keep in mind as I go through these results. But in summary, we're seeing persistent region change, and both related to the heat wave. There was a significant changes in biodiversity, evenness, and richness in both regions. And this is despite the differences in kelp loss in Monterey. And the majority of the species did decline in densities. And this has huge potential impacts, long-term impacts on the health of the marine ecosystem. And then lastly, I think, which is the most important part of this presentation is that long-term monitoring is essential to understand these potential delayed impacts, particularly for maybe these longer living species. And the work that you guys are doing every single day is super important to understanding this. And as Jackie mentioned, in California specifically, we recently celebrated our 20 years of kelp forest monitoring. And I don't know if people know this,
Excuse
but
me.
a
Thank
huge
you.
this is a huge feat for any scientific organization. 20 years is a huge deal. And you might not have realized that we released a California monitoring report in 2024, or sorry, we released it last year using 2024 data. So if you want to take a look, that's available. And we plan to make more of these every single year. So stay tuned. This is just the beginning of what we plan and hope to grow upon in the next forever. And then that's it. That's the end of my presentation. So happy to stay on and answer questions.
Thanks, Annie.